Alright, problem number 2. The asymptotes of a hyperbola are y plus 5 equals plus or minus 2 times the quantity x minus 1, and the foci are 1 plus or minus 2 times the square root of 5 minus, negative 5. Alright, what do we want to do? Well, we want to write the equation of the hyperbola in parametric form, a rectangular form. We want to find its eccentricity, and we want to graph it. So, how are we going to start? Well, I am going to start by using these asymptotes. Boop a doop boop 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 boop. I'm going to pluck that y plus 5 right here, and I'm going to use that in my equation. I know from that equation that I will end up with a y plus 5 squared over something. And then I know I will also have an x minus 1 squared term. Now, at this point, I don't know which one should be positive and which one should be negative. Remember that the positive one tells you the orientation of the hyperbola. So let's look over here at these foci. Notice that the x value is the thing that is changing for the foci. The y value is consistent, which means that this hyperbola is horizontal, which means that our x term needs to be positive. So I'm going to write my x term to the left of my y term, and let's put that there, and I will subtract my y term from my x term, and remember this will equal 1, and now I need to figure out what those denominators should be, and to do so I need to use this slope. So remember that the slope is always in the form of either b over a or a over b. And which is which? Well, you need to think about the hyperbola in question. Think about how this piece is going to work. First off, remember that your a value is with the positive term and your b value is with the negative term. That is going to help us identify whether or not we need a over b or b over a. Well, notice that a is with x, which means that a is running horizontally, which means it is our run. And b is with y, which means it is going vertically, which means it is our rise. And so we need b over a. But here's the problem. You need to be very, very careful with this, because let's look at this bit right here. The fact that I am adding and subtracting 2 times the square root of 5 from the center point there, 1 comma negative 5, verified over here as well with the 1 and the negative 5 right there, if we take the opposite of each. We know that this is our c value. So that's a problem, because remember, for a hyperbola, we know that c squared equals a squared plus b squared. It looks just like our old friend Pythag. And so we know that this quantity c, which is the 2 times the square root of 5, we know that that expression squared equals a squared plus b squared. My pen has not been working well recently. I might need to get a new one. So let's square this out. Well, how do you square 2 root 5? Well, squaring an expression there with multiplication in it is akin to distributing that squared to each term. So I have 2 squared times the square root of 5 squared, which means really I have 4 times 5, which is 20. And so I'm going to use that value. I'm going to use that value. I know that 20 equals a squared plus b squared. And if you look at our number here, that slope, that 2, what we know is that 2 is in the form of b over a. But here's the problem. B over a also needs to fit this bill right here. If you square them and add them together, they need to add to 20. So 2 you need to think of as a fraction. So think of it as 2 over 1. That's the easiest way to turn a single number into a fraction. But does it fit this bill over here? Is 2 squared plus 1 squared equal to 20? Well, no. 2 squared is 4, and 1 squared is 1. 4 plus 1 is 5, not 20. So it can't be 2 over 1. So maybe it is some other fraction that's equivalent to 2 over 1. Well, how about 4 over 2? Is 4 over 2 going to be b over a? Well, let's check it again. If 4 over 2 is going to be our form for b over a, then we need to have 20 equals 4 squared plus 2 squared. And is that true? Well, 4 squared is 16, and 2 squared is not what I just wrote. 2 squared is 4, and 16 plus 4 is indeed equal to 20, which tells me that this is my winning combination for B and A. So I know that B equals 4, and I know that A equals 2. And I knew from before that C equals 2 root 5. So there's my A, B, and C. Again, be careful not to just immediately jump to the easiest solution. You need to make sure everything fits together. So what have I done? Write the equation of the hyperbola in parametric form and in rectangular form. Well, I can do rectangular form now because I figured out that A was 4. So I get a 4 squared there. And I figured out that B was 2. Am I crazy? No, yeah, I'm crazy. I read that backwards. My bad. A was 2, so I have 2 squared there, and B was 4, so I have 4 squared there. So there is my rectangular equation in the factored conic form. Now let's go ahead and write this in parametric form as well. And again, it's pretty straightforward, almost as quick and painless as an ellipse, with one exception. Here we need to remember that when we do our parameterization, we need to put the secant with the positive term. So here that means that x will have my secant term, so x equals 2 times the secant of theta plus 1, and y equals 4 times the tangent of theta minus 5. So there is my ellipse in parametric form with a parameter theta there. So we want to find the eccentricity, which again is just c over a, which means it is 2 root 5 over my a value of 2, which means it is just the square root of 5, which is roughly like 2.4, I think. That's totally wrong. It is 2.236-ish. So there's that. Found my eccentricity. Got the equation, both forms of the equation rather. So last thing I need to do is sketch the graph of this hyperbola. Now I prefer to sketch things from parametric form because I can look at this and be like, yo, look at that. There's my center, 1 comma negative 5. So let's do that. Let's go boom, and let's go boom, and let's say 1 comma negative 5. 1, 2, 3, 4, 5, boom, right there. Okay, what else can I do? Well, look at the 2 that's with your x term. That's telling me from this center go 2 to the right and 2 to the left. Now, the 4 with the y is telling me from that center go up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. So I didn't plan this out very well, did I? But there you go. We can now draw in our box. Boop, 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 boop. Which means I can draw in my asymptotes, which you should be able to look at and see that we should have a slope of plus or minus 2 if you're looking at both of these. So there's that. Last thing we need to think about is am I dealing with a horizontal or a vertical? Well, it's horizontal because my x term is positive, or in parametric form it's horizontal because my x term is the one that has the secant. So I can now graph this in. I have my vertices on that box, and then it's going to curve up and approach those asymptotes. So there you have it. This is our hyperbola. And we're done. There's all of the information-ish for you. You can see most of it.